Bismillahir Rahmanir Rahim. We now look at the segment, the TCP packet. A TCP packet is called a segment. And these are the contents. Okay, we have the header, which is 20 to 60 bytes, and the rest is data. We have in here source port address 16 bits, destination port address 16 bits, sequence number. Okay, every packet will have a unique sequence number in that connection. Okay, and we have acknowledgement number 32 bits. So the sequence number and the acknowledgement number are both 32 bits in size. We have the header length, 4 bits. The way we calculate the header length in TCP is similar to how we do it in IP. And then we have some bits in here. Okay, these are all 1 bits. When these bits are set, there will be a certain function that they will perform. Okay. When we send an acknowledgement in the packet, in the TCP segment, this field will only be valid if the acknowledgement bit is set to 1. If this bit is not set to 1, this value in this field will not be valid. And why do we need to have an acknowledgement together with the sequence number in the same packet? So we have the scenario where a sender sends the packet to the receiver, and this packet is requesting some information from the receiver. Now the receiver has 2 options. Okay, according to TCP, it must send an acknowledgement for this packet. So the receiver can do 2 things. It can either send 2 packets, one for acknowledgement and one for the data requested, or it can combine the 2 in 1 packet, right? It could combine the 2 in 1 packet. So you will have the data sitting here, but you can also send the acknowledgement number in the same packet. So we are saving a packet in this case. But as I said, if we want this field to be valid, the acknowledgement bit must be set. The next we have in here is the urgent bit. The urgent bit, when this is set, the packet will be given high priority, okay, a VIP status. And it will, as soon as it arrives at the receiver, it will be processed. It will not wait. Why do we need this? Sometimes when we send a packet and then we realize later that there was an error in that information that we sent, we can immediately send another one with a correction. But because the later packet that we sent has got a sequence number that is after the first packet we sent, if we don't put the urgent bit, if we don't set the urgent bit, then it means the packet will be, with the error, will be processed first. So to avoid that, if we set the urgent bit, this packet will overtake the first packet and get processed first. The push bit is set when we want to push information to the other side. If we want to reset the connection that we have established and restart, if we want to reset the connection, then we have this bit. At the beginning, when we are establishing the connection, during the connection establishment phase, we send information on both sides for synchronizing the connection. Synchronization information, so the packet will be a synchronization packet if this bit is set to 1, the SYN bit. And finally, when we want to end the data transfer connection, we send the packet with the FIN bit set. This is the finish bit. So when this bit is set, it means the side that is sending it will now finish data transfer. Okay? It will not send any more data. It can send acknowledgements, but it will not send any more data. And then we have the window size. The receiver, when it receives packets from the sender, it will send the updated window size, its receiving window size. And the sender cannot exceed this size in bytes. And then we have checksum for error correction and detection, and we have urgent pointer, which is used along with the urgent bit. We have options and padding for up to 40 bytes. So these are the 6 bits that we have already discussed. If we were to put this TCP packet in the context of the IP packet, then it would be something like this. So we have the 32-bit IP address, source IP address, destination IP address. We have the other contents of the IP header. And after that, we have the TCP header sitting inside it. Okay? And we will have the data attached to it. In the next video, we will start looking at the different phases in TCP.